Hello and welcome, physics students. This is Mr. Steinerson, and we're going to go over some basic vector ideas in this video. One thing that we are going to focus on is what is a vector, and how do we apply this to different situations that we may run across when we're analyzing motion. So one of the things I want you to point out is that vectors can represent lots of different quantities. In this case, this one is representing the wind speed, and the red vector is representing the current in this situation. Both of these are acting on my object, the boat. And if they are pointed in the same direction, they are going to have a resulting vector that is pointing down the river towards the top of the page. Now, not all vectors always do this, but this gives a good example of how we can combine vectors to make a resultant. So what we're going to take a look at in this case, because they're both pointing in the same direction, is we are going to simply connect them tip to tail. So I draw the first vector, let's say it's 5 meters per second. Then from the tip of that vector, I'm going to connect the tail of the next vector, and now I can add those together. The 5 plus 2 makes a new vector, or a resultant vector, equal to 7. We're going to use this term resultant a lot, but it really just means the combination of all the vectors. Now you might be asking yourself, well, what would happen if they're pointing in opposite directions? Instead of adding, we'd subtract. Now, the other logical thing is what happens if they're not in the same direction? Either both pointed upwards or both pointed downwards. And that can be a situation like this, where we have the current and the wind is now pointing to the side. So it's actually moving from this part of the page over to the left side. I'm redrawing that up here, and it looks like I have a situation that it looks like a triangle. In fact, in many of these vector situations, we're going to want to think about right triangles, and our resultant is from the beginning over to the end. So this becomes my resultant vector right here. That is a combination of both the push from the wind and the current. So the true direction and velocity of the boat will be this diagonal. Hopefully you can kind of mentally picture that in your mind. And this is the idea of a resultant vector. Well, how this becomes important is we're going to have lots of different examples, whether it be like this one where there's a person pushing a lawnmower, and as they push on the lawnmower, there's a horizontal force from their push, but we know that the lawnmower also is probably getting pushed down, or at least pulled down from gravity, into the vertical direction as well. So there is this other component that results through a combination of both the horizontal and the vertical. You're going to get the actual force, this diagonal, that is being applied to the lawnmower in this case. So we're going to take a look at those. If we knew the angle, we would be able to calculate what these other sides were. We're going to talk about that also. The next example might be involving some, like kicking a soccer ball or a football. And as you kick that football, there is a force that's an angle. But in order to calculate maybe the velocity, or even if you're thinking about force, we need to break that down into the x and the y parts that make up that diagonal force. So once again, we're going to think right triangles, and we're going to be able to find an x component, and we're going to be able to find a y component of this force. So that's what I'm going to take you through in this video, is how to break those things down into both x's and y components, with the big idea that we always want to think about right triangles. And we're going to use a lot of the math that we already know how to do with right triangles, and looking for those x and y components of that right triangle.